Hey everyone, welcome to Models and Agents, episode 26 for April 5th, 2026. Let's dive into what happened in the AI world today. And trust me, it's been one of those genuinely exciting days where you can feel the pace of progress accelerating. The top story this episode is one of those moments that makes you sit back and smile because it directly attacks one of the biggest complaints in the agent space. Kevin Gu open-sourced AutoAgent, a system that builds a meta-agent capable of autonomously upgrading its own harness until it reaches number 1 on whatever target task you give it. The harness here refers to everything outside the raw model. The system prompts, the tool definitions, the output schemas, the evaluation logic, the few-shot examples, basically all the brittle scaffolding that usually makes agents frustrating to deploy in production. What's particularly elegant is that AutoAgent uses the same base model, in this case Claude, for both execution and evaluation. This shared architecture gives it superior failure analysis and iteration quality compared to human oversight or using a different judge model. The meta agent doesn't just guess what's wrong, it understands the exact quirks, tokenization behavior, and instruction following tendencies of the executor because they're the same model family. In under 24 hours, this system topped Terminal Bench for coding tasks and completely dominated spreadsheet-based financial modeling benchmarks. That's not a small achievement. This result directly challenges the common complaint that agents suck. AutoAgent suggests that the real limiter has rarely been the underlying model itself. It's almost always been the quality of the harness. Once you remove the human bottleneck from the optimization loop, the performance jump can be dramatic. For practitioners, this is huge. You can now point this system at almost any domain-specific task: legal contract analysis, financial forecasting, DevOps automation, scientific literature review, and let it self-optimize into a specialized expert. The full implementation is already available on GitHub, and the barrier to experimentation is remarkably low. My take? This is one of the most important practical advances in agent development we've seen in the last year. It shifts the mindset from "how do I prompt this model better" to "how do I build a system that discovers the best possible harness for my use case." The biggest limiter for agent performance isn't intelligence, it's configuration quality. AutoAgent turns that configuration problem into an optimization problem the model can solve itself. Let's stay on this theme for a moment because the engineering insight here is deeper than it first appears. Everyone talks about self-improving agents as if the model simply gets smarter through some magical feedback loop. In practice, AutoAgent's real breakthrough is that it treats the harness itself as the primary optimization target rather than trying to improve model weights. The core insight is that most agent failures are actually systematic and reproducible once you have a reliable critic. By using the same model family for both acting and judging, the critic shares the exact same strengths, weaknesses, tokenization quirks, and instruction following patterns as the executor. This creates much tighter, more coherent feedback than a human reviewer or a different model family can provide. The meta agent then performs a kind of program synthesis over the entire configuration space, mutating system prompts, adjusting JSON schemas, rewriting tool descriptions, changing error recovery strategies, and continuously measuring success on a held-out validation set. Of course, this comes with overhead. Each iteration requires multiple full test runs, which can get expensive, but it completely removes the human bottleneck that traditionally made high-quality domain-specific agent tuning prohibitively expensive and slow. The quality gains are most pronounced on long horizon or highly structured tasks where brittle tool calling, prompt drift, or subtle schema mismatches usually kill performance after a few steps. That said, there's an important gotcha. The meta optimization process itself needs careful bounding. Without limits on search depth or compute budget, the system can drift toward ever more complex but increasingly fragile configurations that overfit to the validation set. So when should you actually reach for this approach? I'd say use it for any recurring domain task where you can define clear success metrics and you're willing to spend 10 to 100 times more upfront compute to get a truly specialized harness. The old alternative of handcrafting prompts across many different models scales extremely poorly as task complexity grows. Moving from frontier agent techniques to practical local deployment, this week also saw strong community validation of the new Gemma 4 models as genuinely useful local agents, especially the 26 billion parameter mixture of experts variant when running on constrained hardware. The local LLM community ran a fascinating 30-question blind test covering code, reasoning, analysis, communication, and meta-alignment, with Claude Opus 4.6 acting as the judge. The results were closer than many expected. Chuen 3.527b won 46.7% of the matchups but suffered noticeable format and refusal failures on about 10% of questions. Meanwhile, both Gemma 431b and the 26BA4BMOE variant achieved identical average scores of 8.82, remarkably competitive. Gemma 431b particularly dominated in communication and writing tasks, while the 26B Mixture of Experts version showed impressive efficiency when it didn't error out. Even more impressively, Gemma 431b placed third on the challenging food truck bench, beating GLM5 Chuen 3.5 397b and several Claude Sonnet variants. On the practical side, community reports are increasingly highlighting Gemma 4, especially that 26BA4BMOE, as an exceptionally strong local agent for Windows machines and 16GB hardware. Users consistently reported outperforming Chuen 3.527b in real-world coding speed, multilingual support, systems and DevOps tasks, and creative work. People are getting impressive results with far fewer prompts and much less looping behavior. Things like generating clean SVGs on the first or second try, or building a surprisingly capable Doom-style raycaster in HTML and JavaScript. Alibaba's Chuen team also dropped an interesting new reasoning algorithm this week that could have significant downstream impact on future models. They introduced a reinforcement learning variant that weights each reasoning step by its actual influence on future tokens, rather than applying the traditional uniform reward across all steps. Early reports suggest this change can roughly double the length of coherent thought processes in reasoning models before they start to degrade. This feels like a meaningful step toward more reliable long-chain reasoning, especially for local models that need to maximize capability within tight compute budgets. On the agent and tooling front, there were several notable releases that make local and autonomous workflows much more practical. First, there's now a one-click OpenClaw setup that combines Gemma 4 and Chuen 3.5 with turboquant caching and context warming. This makes viable local agents possible on a 16GB MacBook Air or Mac Mini at 10 to 15 tokens per second. The team also pushed patches to the la-ma.cpp turboquant implementation that significantly improved tool calling reliability. In the Practical Tools section, the Kreuzberg Document Intelligence Library just hit version 4.7.0. This Rust core extraction library now supports 248 languages through TreeSitter and delivers AST-level code intelligence for functions, classes, imports, and symbols. The improvements are striking. Structural F1 scores jumped across 23 different formats. LaTeX went from 0% to 100%, and PDF table extraction improved from 15.5% to 53.7%. It now ships as a clean Open Web UI backend and includes a new tune format that reduces token usage in agent prompts by 30 to 50%. This is going to be a game changer for any agent that needs to deeply understand code bases or complex documents. Simon Willison also released a small but very useful Python tool called Scan for Secrets, version 0.1. It scans directories for API keys and secrets, including common encodings and escaping variants. Built with Claude Code using README-driven development and red-green test-driven development, it's perfect for safely publishing transcripts of local agent sessions without accidentally leaking credentials. Finally, there's a new project called Cadenza that adds intelligent WAN-B integration for agents. The CLI and Python SDK can import WAN-B projects, index runs by configuration and metrics, and return only the highest performing experiments to your agents. It's specifically designed to reduce context rot and help autonomous research loops make better exploration versus exploitation trade-offs. Here are the things you should try this week. 1. Take AutoAgent and point the meta optimizer at one of your existing agent tasks. Give it your current harness for terminal bench style coding or data analysis and see how many iterations it takes to outperform your manually tuned version. The results can be eye-opening. 2. Run Gemma 426BA4B locally using Unsloth's IQ4XS or IQ4NL quants. Try it on coding and vision tasks on 16GB hardware. Use temperature 0.3, min-p 0.1, and image-min-tokens 300 for strong vision performance. 3. Test Kreuzberg 4.7.0 as your new document extraction backend. Feed it code repositories or mixed PDFs and spreadsheets, then compare token efficiency using the new Tune format. 4. If you're running autonomous research agents, integrate Cadenza with your WAN-B projects. The reduction in context rot is dramatic. 5. Get in the habit of running scan for secrets before publishing any local Claude code or agent transcripts, especially detailed logs from AutoAgent or OpenClaw runs. On the horizon, we should expect more releases and quant optimizations for the Gemma 4 family as the community continues pushing local agent performance on consumer hardware. The Chwen team's per-step weighted reinforcement learning technique will likely make its way into future Chwen 3.6 releases. We'll also probably see more agent frameworks adopting structured document intelligence backends like Kreuzberg now that it offers clean AST-level code extraction and smooth open web UI integration. And I expect the AutoAgent pattern of same model critic loops to spread rapidly through other open source agent projects. Before we go, tomorrow keep an eye on how quickly the AutoAgent pattern gets adopted across the broader open source ecosystem. This one feels like it could move fast. That wraps up today's AI briefing. If you found this valuable, share it with a developer or builder who wants to stay current. Subscribe wherever you listen, and I'll see you tomorrow. This podcast is curated by Patrick but generated using AI voice synthesis of my voice using ElevenLabs. The primary reason to do this is I unfortunately don't have the time to be consistent with generating all the content and wanted to focus on creating consistent and regular episodes for all the themes that I enjoy, and I hope others do as well.